Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7 on differential calculus, and then 7.1 it's saying, determine f prime x from first principle if f of x is equals to negative 4x squared. Now, the first thing that you want to do when tackling this question is that you want to apply your rules. We know that we are solving this in terms of our first principle, but then you just want to kind of apply your rules so that you kind of have an idea of what should be your final answer. Now, what that does is that it will guide you in terms of having to land to the correct answer and also being able to identify if you are making any mistakes during the process of doing your first principles, because sometimes it can be a very long and daunting process, right? So you have your f prime x is equals to negative 8x, right? So that's the first thing that you want to do. And then you kind of save that to the side. So you're not writing it. We are not answering the question as yet. Then you have your f of x here, right? Your equation of f of x, which is negative 4x squared. And right beneath, you want to write the equation for x plus h, right? So you want to create this neat approach into your question. Now, what this means is that in the position of x, now you have to substitute by x plus h. So in the position whereby we have x, now we are replacing that by x plus h. Now, at this point, we know that we should expand this, and then this always expands in the very same way always. So it ends up being x squared plus 2xh, and then plus h squared, right? Then at this point, you want to further simplify this by multiplying in with the negative 4, so negative 4x squared. Then we have negative 8xh, then we have negative 4h squared. At this point, you now have the expression for fx plus h. Now you can start with your first principle and say f prime x is equals to lim h approaching 0, where fx plus h minus fx and then h, right? So now you have the equation, and all you just do is you take the expressions and then substitute them there. So now this kind of makes your work neat. Instead of having to want to solve all of this here, you just do it by the side, and then now you just substituting the expressions. So now we have 4x squared minus 8xh minus 4h squared minus negative 4x squared over h. And then we have lim h approaching 0. Now at this point, we know that the negative 4x here will cancel out with this negative 4x squared, because now what happens after we say negative times negative, this will be a positive. So of course, because they will have different signs, they will end up cancelling each other out. So we just do it there. Then we are left with negative 8xh minus 4h squared, and then over h, right? Now, at this point, what you should do is again lim h approaching 0. And then looking at this first term and that second term, we can see that there's a common factor between these two terms, and then that's h. Also, again, you are looking at the fact that you want to cancel off this h here. So you'll factor out the h, and then you are left with negative 8x minus 4h, and then over h. Now at this point, you can see the h and h will divide each other out, and then we are left with that expression there. At this point, I can just drop off the lim h approaching 0. So if you are maybe asking yourself, will they penalize me if I ever miss this in any of the steps? Yes, they will, because you should always keep that. For as much as you haven't substituted with h 0, then you always have to write that lim h approaching 0. So as boring as it is, guys, please follow procedure. Then this is negative 8x minus 4. In the position of h, I will substitute my 0 like that. So now you see that I have dropped the lim h approaching 0. It's no longer there because I've now substituted my h as 0. So we are saying that now h has approached 0. So now my f prime x will say, therefore, f prime x is equals to negative 8x. So that becomes the solution that I end up having. And then if you can check here, I had already confirmed it. So now if I solve and I get to that point, and then I see that it also corresponds to what I would have got if I were using my rules, then that means I am correct. So the beauty of it is that you don't even need to check your memo for that. You can just look at your answer here and then confirm if everything that you did is correct. Right. So now let's go to 7.2.1. We have determine f prime x if f of x is equals to 2x cubed minus 3x. So can start by writing that equation there. And then at this point, we know that all we have to do is apply our rules, which says we must take the exponent, jump down and multiply the coefficient, which is 3 multiplied by 2, that's 6. And then if we subtract 1 from that 3, we end up with 2. So that's 6x squared. But then here, we have an exponent of 1. We know that if the variable is just like that, it carries an exponent of 1, then that's 1 multiplied by negative 3, which would be negative 3. But if we subtract 1 from this exponent, which is 1, 1 minus 1 is 0, and then x to the exponent of 0 ends up being 1. And then negative 3 multiplied by 1, that's still negative 3. So it's just going to be like that, right? So the trick is every time you are given a variable that has an exponent of 1, then the derivative will be the coefficient, right? So note that every time you are given a variable with an exponent of 1, the derivative will be the coefficient. Okay, so that's 7.2.1. Now for 7.2.2, note the format that they've given us. So that's dx, and then let's use a square bracket, because those are bigger brackets, and then we have a cube root of x squared plus 2x to the exponent of negative 5, right? Now at this point, this is what you want to do. You want to prepare your expression for derivation. So the first thing that you have to note is that we cannot derive whilst our variable is in sub form. So do not derive whilst the variable is in SAD. So never ever derive while your variable is still in SAD form. Remember, whenever you want to derive, you want to make sure that your variables are in exponential form. Right. So now the first thing that you want to do is you prepare this for derivation. And since you haven't derived, you still need to keep this dx. So that's dx. And then having to express this is 7. And then x squared over, we know how to take this out of the cube root. So you take the exponent of the variable over the exponent of the root there. So that's 2 over 3. And then this one, there is no problem with it. So we're just going to go ahead and write it the way it is, right? Then at this point, we can say that everything is proper. That means we can now derive. Now, if we are in the position of deriving, we get rid of this dx. So you just put an equal sign like that. And then you start with deriving. So deriving, we need to take the exponent, multiply by the coefficient. So if we say 2 over 3 multiplied by 7, that's 14 over 3. And then x. Now if we subtract 1 from this 2 over 3, that's going to be negative 1 over 3. So remember, exponent jumps down to multiply the coefficient, then subtract 1 from the exponent. Then at this point, we take the negative 5 here, multiply by the coefficient again, so that's negative 10. And then if we subtract 1 from the exponent, that's negative 6. Now at this point, it is done. So do not write any dy dx or f prime x there. You just simply leave it like that. Okay, so now let's go to 7.3. 7.3 says for which values of x will the tangent f of x is equals to negative 2x cubed, or will the tangent 2 f of x is equals to negative 2x cubed plus 8x have a positive gradient. Now, if you are to check my video on the secrets of calculus, the cubic function, you will remember that anything that touches on gradient, I said that we have to look at our f prime x. So we are still deriving in a way here, right? So this is they're talking about the positive gradient, but then we know once they mention gradient, we have to consult the gradient function. So our f prime x is known as the gradient function. So this is what tells us about our gradient. Now, if they're saying that the gradient needs to be positive, we know that positive in maths can be indicated by saying greater than 0. So in other words, we are looking for where f prime x will be greater than 0. So that's the meaning. So the first thing that you have to understand is how to interpret these questions. So having a positive gradient means that our f prime x is greater than 0. But again, if we go back to that, we know that this means that f prime x greater than 0 means that our f prime x needs to be above the x-axis, right? So again, if you go back to that video, I said f prime x greater than 0 means f prime x needs to be above the x-axis. What are we talking about now? Looking at the a here that we have, we can see that our value for a for the cubic is negative. So if it's negative, we know that the shape of the cubic function that we're going to have is something like this, right? Now, if we have our shape of the cubic being that, we know that the shape of the gradient function, which needs to be a parabola, needs to be a what? A concave down graph. So it needs to be a concave down graph, right? So this will indicate our f prime x, and this one would have to indicate our original graph. But then we said the gradient must be positive. So if we go ahead and just draw a horizontal line here to represent our x-axis, that means we are looking for the points in here. We are looking for the points where our f prime x will be greater, will be above the x-axis. Right. So our f prime x above the x-axis, that's what it means to have a positive gradient. So all these gradients below the x-axis are negative, and all these gradients here above the x-axis are positive. Right. So now I've only made you understand the question. Let's get to solving the question. So 7.3, we have f of x is equals to negative 2x cubed plus 8x. Now this is f prime x is equals to negative 6x squared and then plus 8, right? But then, since they said that our gradient needs to be positive, we know that this translates to a negative 6x squared plus 8 must be greater than what? Than 0. Right, so that's f prime x greater than 0. Now at this point, we want to divide by a number that is divisible to 6 and 8. So that's negative 2. So negative 2 left-hand side and right-hand side. Now this will give us 3, positive 3x squared, and then negative 4. But then remember, every time we are dividing with the negative and then we have an inequality sign, what happens to the inequality sign is that it changes the direction, right? Because we've divided with the negative value. So that's 0 here. Now at this point, what do we want to do? We want to further continue solving this. So this is 3x squared. Take the negative 4 over to that side. It will be positive 4. If we divide both sides by positive 3, it's a positive value, so the sign doesn't change. Only changes if we are dividing with the negative value. Note that. Then at this point, we want to square both sides. But then we know when we square, we now have our critical values. And then our critical values, remember, every time you are squaring, your answer comes out as a plus minus. So this will be negative 2 over root 3. And then also as well, positive 2 over root 3. Right. So these are the critical values that we have. But then we haven't reached to the final answer. Now the critical values are these points here. critical values will be indicating the x-intercepts here. So that's negative 2 over root 3, and then here positive 2 over root 3. Now the question is, will the values be found outside the critical values, or will the values be found inside the critical values? Now we just said that f prime x greater than 0 means that our f prime x needs to be above the x-axis. And then we can see that this graph here is above the x-axis in between the critical values. So if that is the solution, then that means our x is an element of negative 2 over root 3 is to positive 2 over root 3. Or if you prefer this notation, you will say negative 2 over root 3, and then you have the x here, and then you have this and that. So 2 over root 3. Right. So your choice in terms of the notation that you prefer, but all of this means that x must be an element from negative 2 over 3 to positive 2 over 3. So these are the values that will produce positive gradient for the tangent. Right. Okay, so with all that being said, guys, please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.